Good morning. So we're Group Hackberry, and we're excited to be here today to tell you about our study. So LeAnn is going to do the introduction. I'm going to talk about our data, and then Sean is going to talk about the method, and then Tony will talk about the results, and Kyle will do our conclusion.
Okay, so I'm LeAnn. When COVID-19 hit the US in March of 2020, there were reports all over the world of pollution reduction. News reports showed empty roads in India and the clear Venice canals. So for this project, we chose to study LA County, California to see if there really was a link between air quality and the reduced number of active drivers due to the COVID shutdown. So why did we choose Los Angeles County? They are known for its busy and alive city, and it is also known for its smog and poor air quality. Southern California is home to several air quality control stations, and at these stations, they test for certain pollutants like CO2, O3, and NO2. Of these pollutants, we decided to study the NO2 levels. So why NO2? NO2, it gets stuck in the atmosphere from burning fuels. So it forms from the emissions from cars, trucks, buses, power plants, and other automobiles and equipment. Our null hypothesis for the project is driving-related pollution in Los Angeles was meaningfully impacted by the stay-at-home order in spring of 2020, and our alternative hypothesis is the stay-at-home order in spring 2020 did not have a significant impact on observed pollution levels.
For our data, we actually were able to download 24-hourly NO2 report readings from the South Coast AQMD. The South Coast AQMD is a government organization that actually tracks many different kinds of pollution all around Southern California. We chose to look at the Southwest Coastal LA County Reading Center. That was just because they had the most available data and were able to give us a complete set of information going back the 3 years. So what we got was actually an Excel file with the hourly readouts, and we selected the 10 a.m. level for the purpose of our study.
So in doing our method, we wanted to break down our hypothesis into two separate studies, which are the long-term and short-term. The long-term study, we wanted to look at the overall trends in March 2020 to June 2020 compared to the same time frame in 2019, 2018. For the short-term, we mainly focused on 2020, looking at the weekly mean values of the amount of NO2 in the air and using that data to compare the weeks before and prior for specific stay-at-home, lockdown, and quarantine orders that were being issued. From the data collected, we compared it using line graphs, data tables, and trend lines. We also used other statistics such as the median, mode, total data points, and standard deviation to help be more insight to find a simple cause and effect relation in these two studies.
So taking all this raw data and doing those calculations using that methodology, we're kind of looking at the mean as the mean potatoes number for our investigation here. So as you can see, the mean for 2018 rose in 2019 and then rose again in 2020 for the March to end of June time span, which is very interesting since we expected it to go down. We're actually seeing here that it is increasing by a significant amount to 2020. And to track these, here's the blue trend line is 2020. And you can see it's generally higher, especially later on in the dates, as well as a little bit lower in the beginning, but it does have some larger spikes and generally stays higher, which is an interesting find. And so then looking at our short-term week-to-week results, we took 4 COVID orders, which ranged from going into a state of emergency, going to only essential workers, everyone was required to wear masks, etc. And then looking at the weeks before and after. So looking at the means again, being the meat and potatoes, you can see the means generally decrease by a decent amount in the following week, which is very cool to see that there is a short-term aspect to this, to these COVID orders that did help air pollution in the parts per million, but not in the long term, since these numbers are generally higher than years prior. And here is a graph tracking those mean values. As you can see, it does dip, come a little bit back up, but then after the orders, you can see how they dip into the next order and flow.
So in conclusion, our research and methodology found no correlation between the air quality and the number of active drivers on the road during the COVID-19 shutdown. Our analysis of the effects of the COVID-19 mandates yielded a short-term effect on the NO2 levels in the air. The stay-at-home orders resulted in lower air pollution as we calculated in our weekly means. Given the long-term effect of the stay-at-home orders, they proved no long-lasting effect on the air pollution as a result of our calculated yearly means. Given the long-term effects, we would need to conduct further studies to conclude if there would be any long-term effects on the air quality. The data in the Southeast air quality management data yielded a rejection in our null hypothesis, as the COVID-19 orders did not clearly or directly affect the NO2 pollution levels in LA County on a large scale.